Hope for your well-being. Let's continue our discussion for JEE Mains 2021 August 26 morning paper previous year questions. So the next question was a uniform chain of length 3 meter. So it's given you that there is a chain of length 3 meter and mass 3 kg overhangs on a smooth table with the 2 meters lying on the table. So 2 meter is lying on a table and that means 1 meter will be hanging there. If the kinetic energy of a chain in joule as it slips off the table is K, what's the value of K? So this is an initial situation given you that. So in that case we can say that they are asking for kinetic energy and there is no role of friction. So we can say that the mechanical energy is conserved. So we can say mechanical energy is conserved as there is no non-conservative forces. So as the mechanical energy is conserved, so I can say that the kinetic energy initially plus potential energy initially will be equals to kinetic energy final plus potential energy final. Finally, let's assume the chain completely hangs out, so it will be like 3 meter here. So we can say that initially the kinetic energy was 0, we just release it, and initially the potential. So first we will make a reference line because potential energy depends on reference. So this is a reference line for us, and we should remember that the potential energy for a rigid body will act at the center of mass of the body because gravitational force is a central force. So in that case it will act here. So the potential energy will be equals to mgh. M, the mass of the chain. The hanging part mass is the total mass is 3 kg and 1 kg is hanging, so hanging part has a mass of 1 kg, so 1 mg, and the height, that's the center of mass from the reference line, is 0.5, although it is below the reference line, so the potential energy should be considered as negative. Should be equals to kinetic energy finally when the chain completely slips off is K, plus potential energy will be, now this will be our reference point and it will be at a depth of 1.5 meter. So we can say that the complete mass came here, so we can say that 3 kg 3 m, it's also below the reference line, so it should be negative mg and the h will be 1.5. So the kinetic energy will be equals to minus 5 plus 45. The result will be 40 joule. So the answer will be given as 40 dot. Next answer. Next question. In the next question, it's given you that the electric field in an electromagnetic wave is this. So whatever this will be the maximum value of electric field E naught. Whatever will be the coefficient of x, that should be equals to k, and whatever will be the time will be the coefficient of this value will be the omega. If this wave, although we are lucky enough, we can check first whether this wave is moving in a vacuum or not. So this is a 10 to the power 5, so you can check the velocity is omega by k. So and omega by k is 3 into 10 to the power 8. That means the wave is in vacuum itself. If the wave falls perfectly on a rigid reflecting surface, the wave falls on a reflecting surface, and it's a perfectly reflecting surface of an area. So the area is given as 10 meters square, 100 centimeters square. The radiation pressure exerted by the EM wave on the surface for that exposure of. So radiation pressure we can just calculate, or we can just remember that the radiation pressure will be equals to 2I by C in case of reflecting surface, and radiation pressure will be equals to I by C in case of perfectly absorbing surface. So here we are dealing with reflecting surface, so as the photons will give, so you can calculate, normally you can calculate this also. The pressure will be equals to intensity. I is intensity, so intensity is energy per second per unit area, so 2I by C we have to calculate. Now we already know E, and we know in an EM wave the energy density, if someone asks you electric energy density, then you can say that it is equals to half epsilon naught E RMS square. If someone asks you magnetic energy density, then you can say that it is equals to half B RMS square by mu naught. And you already know electric as well as magnetic energy density is same in EM waves. And if you sum them and total, if you will say total energy density, that means normally the energy density, then it will be the sum of two. And you can directly write like E naught RMS square or half epsilon naught E naught square. So you should have to take care that if you are writing total density, so you should make sure that you should use half epsilon naught E naught square or epsilon naught E RMS square. And what is the relationship between intensity and pressure? So intensity is equals to energy density ED, energy density into speed of light. So if you substitute here, so 2 into energy density into speed, by speed is cancelled, so pressure will be twice the energy density in case of perfectly reflecting surface, and the pressure will be equals to the energy density in case of perfectly absorbing surface. Energy density we can write like half epsilon naught E naught square. So 2 cancel. What is epsilon naught? So epsilon naught will be 8.85 into 10 to the power minus 12 into E naught will be 200 square. So 8.85 into 4 into this will the power will be the power will become here as 10 raised to the power minus 8, and we have to give the answer in 10 raised to the power minus 9, so we have to divide it by 10 further. So answer is 35 something into 10 raised to the power minus 9 divided by this, so 3.5 something. This should be the answer. Moving to the next question, it's given you that a source and a detector move away from each other in the absence of a field. So there is a source, there is a detector, both are moving away from each other. If the detector has a frequency, so the EM wave generated by a detector will have a frequency equals, if the detector detects the frequency, that means the sound is produced by the source and it is detected by the detector with a frequency of 1800 hertz. So that's not the frequency of source, but it's an apparent frequency heard by the detector. Then the original frequency, that means we have to calculate the frequency of a source for a sound moving in this. Both are moving with 2020. We already know that the sound will move from source to listener or source to detector. Then you can say that this is the direction of sound. Any velocity in direction of sound must be taken as negative, and the direction and any velocity opposite to the direction of sound will be taken as positive. So in direction of sound is negative and this will be positive. So basic formula for apparent frequency heard will be equals to real frequency into v plus minus v listener divided by v plus minus v source. So plus or minus will be decided by the direction of sound. We already decided that. So f, the frequency heard will be 8. F dash is 1800. F is the actual frequency. Listener velocity is taken as minus 20. So we should put for a listener velocity as minus 20 divided by the source velocity is 340 plus, sound velocity is 340 plus 20. So 1800 is equals to F into 320 divided by 360. So this is cancelled. So 4. So F will be 1800 into 9 by 8. Answer. Let's move to the next question. It's given you that there are two spherical balls, each of masses with the radius as shown in a radius of 5 centimeter. Each are thrown vertically upward a same line at an interval of, so that's taken reference line. The first ball is thrown upward with a speed of in a vertical direction. So let's take this ball is thrown at t is equals to 0 with a speed of 35. The another ball is thrown at t is equals to 3 seconds at the same speed of 35 meter per second. Then these balls will collide at a height of this. So obviously when the first ball has been completes its initial journey, the second ball, when the first ball is coming back and the second ball is going up, then they will collide. Important thing to observe is if someone asks me that the ball is thrown at a speed of 35 meter per second, so we already know that in 1 second under the gravity the speed will be decreased by 10 meter per second square. So if someone asks me what will be the time taken to reach to the topmost point for the first ball, will be equals to 3.5 seconds. So after t is equals to 3.5 second, the first ball will reach to the same point. Now this is the understanding. First we will calculate the position where they will meet. So we already know they will collide. They will collide. They will collide when they reach at same position at same instant. So the position of first ball should be equals to the position of second ball. So what is the position of first ball? So the first ball is thrown upward with a velocity of 35. So we will write distance equals to ut plus half at square. So u, that is 35, the time taken by the first ball is t, plus half acceleration is g, and the time is t square. This will be the positions of first ball anyhow, and the velocity is taken in upward direction and g is taken in downward direction. So let's take this as negative. While in the other case we have to write initial velocity is 35 and the time is t, plus time will be taken as t minus 3 because this ball has been thrown after 3 seconds for each instant. So you should have to write 3 minus 3 plus half. Again the ball is going in a upward direction. So g will be taken as negative minus t into time taken as t minus 3 ka whole square. So when we'll solve this 35t will cancel. This will left with minus 105. Half of g can written as 5, so 5t square. So we can write like minus 5t square minus minus plus 5 t minus 3 the whole square is equals to 35 into 3 is 105. 105. So 105 we just divide, and this is like a square minus b square. So a square minus b square is a plus b into a minus b. So just add both of them. So 2t minus 3 into 2t, t minus 3 minus t will give you minus 3. 3 will be equals to 21. So 2t is equals to 7 plus 3 is 10. So t is equals to 5 seconds. So after 5 seconds, these balls will collide, that we came to know, and we already know that the first ball will reach to the topmost point at t is equals to 3.5 seconds. So after 5 seconds, the first ball will make a journey of in a downward direction. The first ball will make a journey in a downward direction for 1.5 seconds. And then this is the instant where they will collide. So let's analyze this part. For 1.5 seconds, what will be the distance traveled by this ball? So let's take this distance as d1. So we already know that it's a case of free fall, so we can calculate s is equals to ut, initial velocity is 0, plus half acceleration is g, that is 10, and t square is 1.5 whole square. So this will come out to be d1 is equals to 5 into 2.25, 12.25 meter. We already know that from A to B, that this height that should be d2, we can directly calculate d2 also, that d2 is equals to half g, because initial velocity is 0, into t square, and the time taken to reach from here to there is 3.5 whole square. So that should be 5 into 12.25. So the height at which it collides, that is h will be equals to d2 minus d1. So that should be equals to we just have 5 into 12.25 minus 2.25, that will yield you 5 into 10, that will be equals to 50 meter, because this is 5 into 12.25 and this is 5 into 2.25. So the ball width collides from a ground at a height of 50 meter and h will be equals to 50 meter. The next question: a soap bubble of radius 3 centimeter is formed inside another soap bubble. So a soap bubble is formed inside another soap bubble. So let's take, there are two soap bubbles. One radius is 6 centimeter, the another radius is 3 centimeter. The radius of an equivalent soap bubble which have same excess pressure as an inside. So we need another soap bubble where radiuses are equivalent, where the excess pressure is same as this. We already know that in a spherical body the excess pressure is great in a bubble is greater than inside. So if you have a soap bubble, the outside pressure is P atmosphere. If you go inside, because of the molecules, because of the surface tension, the excess pressure will become P atmosphere plus 4s by r या 4t by r, where s or t is a surface tension. So let's take 4t by r. So if I will enter here, so here the pressure is P atmospheres, and when I enter this side, so this the pressure at A will becomes P atmosphere plus 4t by r, and here r will be the 6 centimeter. Then if I will enter from here to here, another inside, the pressure will increase, so it will become plus 2t by the pressure at till a the pressure is this. So if I will reach to the point B, then the pressure will become plus 2t by 3 centimeter, because every time when you will enter inside this, the pressure will increase. So pressure at B will be equals to P atmosphere, that means pressure inside both the bubbles will be equals to P atmosphere plus 4t by 6 centimeter plus 4t by 3 centimeter. If you have an equivalent soap bubble, so let's take the pressure here as P atmosphere. If you will go inside, then the pressure inside an equivalent, that is also will be equals to PB, will equals to P atmosphere plus 4T by R equivalent. So both the pressures are equal as the statement says. So we can say that 4T by 6 centimeter plus 40 by 3 centimeter, that is the pressure inside this, both the combination should be equals to excess pressure inside the equivalent soap bubble. So R equivalent will be equals to 6 centimeter into 3 centimeter by 6 centimeter plus 3 centimeter. So the answer will be 2 centimeter for this. So that's all for today. Thank you very much. Have a nice day. Take care. Keep smiling. Bye everyone. Please subscribe for more content. Our YouTube channel at sapienseducation.com. Have a nice day. Take care. Keep smiling. Bye everyone.